grade 7s. Helen here, and that means it's natural sciences. What are we looking at today? Well, we're still looking at methods to separate mixtures. So let's get into it right away and see what we're doing. To revise, we've learned of different techniques of separating mixtures. Can you look at this picture and can you identify all the different methods that we've learned about? Let's start up here at the top. What is happening here? Do you remember we learned about the process called filtration? Here, this was in our last lesson, and we looked at evaporation to separate a mixture which is a solution, and we separate the solute, the solid part, from the solvent or the liquid part. We've also looked at hand sorting, which is something that you do every day of your lives. We have previously looked at sieving. We've looked at magnetism as a property of materials in order to help us separate kinds of metals from each other. So what are we looking at today? Well, today we're going to look at a far more complicated process called distillation. And we're going to examine how we can use this process to separate the mixture, which is also a solution, as we looked at with evaporation. And here we're going to make use of evaporation and condensation in order to distill two different substances. Now I want you to think back to our solution of salt water. And in our solution of salt water, we had a solute, which was a solid salt, and we had the solvent, which was water. And of course, that was a liquid. And we evaporated off the liquid, and we were left with a solid solute. But what happens if our mixture is made up of two liquids? We've got a bit of a problem. We can't evaporate the one liquid and leave the other liquid behind, or can we? Yes, we can, and this is the process of distillation. Now, let's just make sure we remember all of our terminology. We know that when we go from a solid to a liquid to a gas, we are moving through different state changes. And the key is we are adding heat energy, or we could be taking away heat energy. If we add heat energy to a solid, we're going to melt our solid into a liquid. If we continue to add heat energy, we are going to evaporate the liquid into a gas. If that gas has heat taken away from it, we're going to condense our liquid, or condense the gas into a liquid. And of course, we can have the frozen substance by freezing our liquid into a solid. Now, we're not going to be paying attention to the melting and the freezing processes of our state changes today. We're focusing on evaporation and condensation. And we're bringing another property of materials that we have already looked at, and that is boiling point. Now, let's cast our minds back to our lesson on boiling point. We made a very clear distinction between heat and temperature. We said that heat was the energy that is being transferred from one substance or material to another material. Temperature is the point at which those phase changes happens, and temperature is a measurement of how much heat energy there needs to be to bring about that phase change. So we looked at melting point and we looked at boiling point. And today when we look at distillation, we are focusing on boiling point. And you might remember from our lesson, you should remember from our lesson on boiling point, is that different materials have different boiling points. We know that water, for example, is going to boil at 100 degrees C. But you also learned that other substances boil at different temperatures. And in our process of distillation, we are going to rely on the fact that our two liquids that we've got in the mixture have two different boiling points. So let's look at this process, or the principle behind the process of distillation. Here are your key words. We have the mixture, and in this case, our mixture is a solution. And very importantly, it is a liquid solution. We're going to add heat energy to our mixture. We know that our mixture consists of liquids with different boiling points. And so as we add heat energy, we're going to see that the substance, the liquid, that has the lowest boiling point, in other words, it boils soonest, is going to evaporate, and it's going to get trapped in this little container. So the evaporation is going to take place, and then it's going to condense in our little collecting vessel. What we will have left behind is the liquid with the higher boiling point, right? So we're separating the two liquids based on their different boiling points. Now, here is the proper apparatus that we use for distillation. We would need something to provide us with the heat source, the heat energy. We would need a couple of stands to hold up all our apparatus. So a lot of what we're seeing here is just supporting stands and clamps to hold the apparatus. We need a flask, which is going to contain our mixture of the two liquids. We need a way of reading the temperature. And do you remember what we use to read temperature? We're going to have a thermometer. We're going to be sealing that apparatus very carefully. We're going to have a collecting vessel, maybe some kind of glass vessel here, in order to collect the liquid. And then we have what is called a Liebig condenser. Now let me show you what we've got. We've got a tube that is hollow, and that tube is inside another tube, and in the outside glass cavity we're going to have cold water. So we can see that we've got cold water coming in, and we're going to be able to circulate the water so that we keep the water cold, and we're going to have our process of condensation happening inside this container, the Liebig condenser. So let's look at the process. You should be able to predict what happens. We add heat energy to our mixture. The mixture with the substance with the lowest boiling point will start to boil first. It will evaporate and move into the Liebig condenser, where we've got the cold water circulating around the outside of our collecting tube, and that substance will condense and collect in our cylinder. What we will have left behind, of course, is the substance with the highest boiling point. And we are measuring the temperature carefully so that we don't accidentally get this mixture to the temperature where the next substance, the other liquid with a higher boiling point also starts to evaporate. So it looks very complicated, but it's actually simply using the fact that different liquids have different boiling points. Where would we use this process in real life? Well, many industries rely on distillation. First of all, one industry is the distillation of alcohol. Now, if you think back to the episode where we looked at different boiling points, we saw that ethanol or alcohol boiled at 78 degrees C, whereas water boils at 100 degrees C. So this is a photograph of a kind of condenser. Here's our original matter or our mixture, and this is a very sophisticated condenser. It's not a Liebig condenser, it's a copper condenser, but the principle of distillation is the same. The alcohol will be separated from our mixture first, and it will be collected, and as long as we keep the temperature of the mixture in the mixture part of our apparatus well below 100 degrees, but above 78 degrees, we are going to be able to confidently separate alcohol from water. Now, this process is also used in the distillation of vinegar, for example. One of the most important industries for our modern economy where distillation is used is the distillation of crude oil. So oil goes through an incredibly sophisticated process of distillation called fractional distillation, because present in oil we haven't just got two substances such as ethanol and water. We've got petrol, we've got diesel, we've got other substances that are going to be used to make other products. And this process of distillation of oil, you can see how high our fractional distillation condensing tube is, so that we can get the liquid, the mixture of oil, to a certain temperature. We can distill off the substance that has the lowest boiling point. If we then increase the temperature a little bit more, we can distill off the substance with the next highest boiling point, and so on. Now, where are you familiar with using products that have gone through a distillation process? Well, if you use perfume, or if your mom uses perfume, you will understand that what we have is a liquid. And the original mixture had a little bit of alcohol in it. It had a little bit of, or it has a little bit of aromatic substances called esters, which you learn about in high school. And all of this mixture has to be put together in very precise measurements to make the perfume perfect. And of course, our process of distillation is important there. We've chatted already about making fuels, even foods such as vinegar and other condiments and sauces are used by or are produced by distillation. And once we have undergone a process of evaporating water or salt in terms of desalination of salt water to recover the water, not so much the salt, but to recover the water to make it into fresh drinking water. The water that is left over at the end of evaporating, we then put through a distillation process to make pure water, because we know that here's our big distillation chamber and we're going to be left with pure water that is distilled off. So today you've learned about distillation, yet another way to separate mixtures. Goodbye.